Hello guys, and welcome back to another episode of chemistry. And of course, we are going to continue our study on alkanols. Okay, so specifically today we are going to be looking at the nomenclature chemistry. We are going to be looking at the nomenclature of alkanols or alcohols, which is the trivial name as you may have it. Okay, so do not forget that this tutorial is brought to you by the one and only O3 Schools JAMB CBT Practice app. It's an application that has helped millions of students to gain success in JAMB and to gain admission into universities. All right, so please, your case can never be different. So please make sure you jump on the application today and start practicing your way to success. In a moment, we'll talk about the app, but first, let's see a question from the app. A JAMB Past Question 2014 number 40. It is being displayed on the screen right now. If my editor is on his activeness. All right, so please, it says here that the IUPAC nomenclature of the compound above. All right, as you can see in the first carbon there. Okay, there's an HO or OH group there, showing that it's an alkanol. All right, so then there are other compounds, there are other groups, or some halo groups are there like chlorine and bromine, all right? But that is not the major thing there. The major thing there is that OH group. It shows that that is an alkanol. So please, if you want to name what alkanol, you have to stick with us till the end of this class. We'll come back to this question at the end of the class and not before, because we believe here in O3 Schools that we need to teach you first. Then any question that comes after, you should be able to answer it. All right, we do not do guesswork here. You need to learn first. All right, so please stick with us to the end of the class. We'll come back to this question and many more from this application. So please make sure you get your app on your phone and make sure you start practicing. The app is also available for PC. Okay, so please, you can just send a message on WhatsApp. Our contact number is on the app, so send us a message and then you can get the PC version. All right, so please, it's important to know that this app has all the past questions you need rather for your examination, so you don't need to bother about going to buy past question outside. There are lecture notes on the application structured according to the JAMB syllabus. Some of you read without your JAMB syllabus, and that is a big no. All right, make sure you study according to your syllabus. So once you have this app, there's no need to go and buy textbook outside. Then there's a question search feature where you can search for question according to topic. And what's more important is the mock challenge every Saturday. There's a mock on the app, a UTME mock that is organized for all students that are writing JAMB for this particular year. All right, you compete with your mates, win a lot of prizes, get used to JAMB Past Questions, get used to JAMB likely exam questions, and of course you see your results released every Saturday, because the mock is every Saturday till 1 week to your JAMB exam. So that way you're able to better prepare yourself and track your progress. So please jump on the application immediately. In fact, you have no time to waste. Jump on the application immediately and start practicing. So let's go see nomenclature of alkanols today. Nomenclature, let me bring the speed down. Nomenclature of alkanols, okay, or the alcohols. We said the trivial name for alkanols are the alcohols, and we say that very importantly, they are characterized by the hydroxyl functional group. Okay, they are characterized by the hydroxyl functional group, which is this OH group. Okay, so once you see OH group, you should know that we're talking about an alkanol. All right, and of course, if we want to also name what alkanols or alcohols as you may have it, it is very important that we give respect. All right, we give respect to this is Ichie of the alkanols group. Okay, so if you see a compound that has OH group, and then you are told to now name the compound, it's very important that we give the red cap to this OH group, because it is very, very, very important. All right, where we're naming our alkanols. All right, so let us continue. We talked about the general formula in the last class, so we're not talking about that now. All right, so let's see examples of alkanols. The simplest alkanol, which we have seen, I thought we saw that in the last episode also. The simplest alkanol is methanol. Okay, it has the formula CH3OH. All right, that is C. All right, now OH right here, H, here, H, here, H. This is the simplest alkanol, having one carbon atom. All right, as you can see evidently. Then of course, we now move further. Let's say we now have two carbon in the formula, okay, or in the compound or in the structure. We have C, here have OH. Here is our H. here is our H, then here is our H, here is our H, here is our H. And this one, we call it what now? Ethanol. Ethanol. And this ethanol is actually what? CH3, C123, that is CH3, then C12, CH2, then OH. Okay, so that's what our ethanol. So in other ways, you can write it as C2H5OH. Okay, so let us continue. Let's say we now have what 3 carbon atoms. Okay, if you have a 3 carbon atom, for example, we have 1, 2, 3. Let's have our OH is here and not on this carbon. All right, so this, we can complete our structure. This is our H, this is our H, this is our H. Here, this is our H, this is our H, this is our H. This is our H. Whenever you want to complete your structure, always bear in mind that there can only be 4 bonds that can surround a carbon atom. All right, it's very important that we take note of that. That only 4 bonds can surround the carbon atom, so that we'll be able to to draw our structure properly. So let's go. This is what CH3. This is what CH and what OH. Then the OH functional group is very important here. Okay, because right now the OH functional group is on. It's on the central carbon. It's not on this it's not on the first carbon. Okay, it's not on the first carbon. It's on the central carbon. Okay, so now let us see. If we number from here 1, 2, 3. Okay, first of all, we know that there are 3 carbon atoms here. So that is what a prop. Okay, propane, from propane, that's a prop. All right, then of course, but the OH is on the on the second carbon. If you number from here to here 1, 2, 3, here will still be 2. The OH functional group will be on the second carbon. If you number from here to here 1, 2, 3, the OH group will still be on the on the second carbon. So the question of taking the shortest distance will not come to play, no matter how we number it. That is why this will be called what now? Propan. Okay, 2 all right, because of the OH. All right, so you number it, you call this what? Propan. Then the position of the functional group is 2, then what? All right, so that's an alkanol. This OL here shows that it's an alkanol. All right, so now let's go further. Let's say we have 4 carbon atoms. Now we're trying to do them. We are going somewhere. Please just follow the class gently and gently. Let's say we have 4 carbon atoms. For example, we have C, 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 C. Then let's say here is what? The OH. Okay, now 1. We can complete our structure. All right, H, H, H. Yeah, definitely will be H, 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 H. Okay, so let's complete. We have completed our structure. Now let us name the compound. So if we number from first of all, first of all, go and locate the functional group. It's on this carbon. All right. So now if we number from here, that is from the left to the right. There will be what now? There will be 1. There will be 2. This will be the 3rd carbon. This will be the 4th carbon. Okay. The OH functional group will be on the 2nd carbon. But if we number from the right to the left, there will be 1. There will be 2. There will be 3. There will be 4. That means that the OH functional group, which is what we're actually looking into, will now be on on the 3rd carbon. So the shortest route to the functional group is one we pick. That's why this numbering will not work, but this numbering will work. Okay, so from what I've been learning so far now, from alkenes, okay, from alkynes, so it's just simple. It's simple. Just follow that order, okay, to name. Okay, so now we have this. The functional group is on the 2nd carbon. So for that singular reason, this will now become what now? First of all, count the number of carbon atoms in the parent chain. This is 1, 2, 3, 4. So that means we already have what? A boot. Okay, so the position of the functional group is what? Is 2. So we can say butan what? 2. All right, 2 what? All. Okay, so this is the name of the compound. All right, so if the compound if the OH group was still here, let's say the OH group was here, OH was here and not here. Okay, if we still number, so that means that numbering from left to right will not work again. You have to now number from right to left, so that this will be the shortest distance to the functional group. Remember, I switched it to, it was here initially, now it's here. So but the name of the compound will not change. It will still be butan 2 all. All right, it will not change. It will still be butan 2 all, because if you number from here to here, this will be 1, this will be 2. To still be on the 2nd carbon. Okay, so please take note of all those little differences. So let us take this a step further. So we have seen methanol, we have seen ethanol, we have seen propan 1 all, we have seen butan 2 all. Let's say we now have a structure like this. Let us use stick form, okay, to represent this. Let's say we have this 1, 2, 3, 4, 5, 6, okay, and then let's say we have what OH here. Let's say we have what OH here, okay. So now, if you want to name this compound, remember our stick form, right? We have dealt a lot about stick form, so that becomes very easy for us. So we have how many carbon atom in this parent chain? 1, 2, 3, 4, 5, 6, because every end and every bend is a carbon atom, okay. So now let's continue. So we have C. So if we number from our left to the right, okay, let us number from our left to the right. So this will be 1, this will be 2, this will be 3, this will be 4, this will be 5, this will be 6. That means our OH group are on position 2 and on position 3 when we number from what? From left to right. Okay, so if we number from right to left, let's see. This should be 1, this should be 2, this should be 3, this should be 4, this should be 5, this should be 6. That's from right to left. From right to left. From left to right, it was 2 and 3. From right now to the left, it will be now on position what now? Position 4. And what? On position what? On position 5. Okay, so we'll take the shortest route to our OH groups. Okay, and our OH groups, the shortest link will be what? This, which is 5. This one is 9. So this is the numbering we'll take. So we'll take numbering from our left to the right to be the correct numbering. So this one now will not work. This will not work. Okay, so now let's take this off. All right, so then we have been able to get our shortest link to the what? To the OH group. 1, 2, 3, 1, 2, 3, 4, 5, 6. All right, so now we have our OH group on the third carbon and on the second carbon. Okay, and then we already know that what the number of carbon atom in this parent chain is what? 6. 1, 2, 3, 4, 5, 6. That is what? An hex. Okay, hexane from hexane and X. All right. So now naming this compound becomes very easy. So I'm going to have what now? Hexane what? 2,3 diol. Okay. Why do we say diol? Because there are what? 2 hydroxyl functional groups in this structure. That's hexane 2,3 diol. Okay, because we have got 2 hydroxyl functional group in this what structure. That's why I'm saying the diol. Okay, let me write it properly. That is what now? Diol. Okay, remember I have to separate it with hyphen rather. So that's hexane 2,3 diol. Becomes very easy, right? So now let us take this a step further. So let's say we have now a very easy one. Let's say we have okay, C, yeah, OH, yeah, OH, yeah, H, yeah, H, yeah, H. So now we have this. It becomes very easy because our OH functional group are on what? On 1 carbon. Okay, they are on the same carbon. Okay, so now we have what? If we number from, obviously we are going to number from right to the left. This will be 1, this will be 2. Okay, so it becomes very easy. Now our carbon atoms, how many carbon atoms are in the parent chain? 2. So that is from ethane. Okay, so that will be ethane. Then now let's name this compound. We have a 2 OH group on position 1. Okay, 1 and 1. Okay, so this becomes very easy. It becomes what? Ethane. Okay, 1, 1. Okay, then what? Diol. Right, 1, 1 diol. Because the reason why I'm putting 1, 1 because the 2 OH group are what? Are on the first carbon. On this carbon, on this side of the carbon, and on this side of the carbon. So 1, but they are both in position 1. So we cannot just say ethane 1 diol. Ethane 1 diol will means that what? It's only 1 OH group that is in the structure. Okay, if you have said ethane 1 diol, ethane 1 diol, okay, it will mean that what? This naming is even very, very, very wrong because you cannot have diol and then you now have 1 OH group. Okay, one is very, very wrong. Okay, and it will only depict, okay, that's what there's only 1 OH group in the structure. So now that's why we now put what? Ethane 1 to denote that what? That both of the OH group, they are on the first carbon. Then what? Our diol becomes very easy. All right, so let's gear up. Let us take this tune a little bit further. So let's say we have this. Now let me just add some other substituent to it to make it easier. 1, 2, 3. Let's say here is what? OH, and then here we have what? CH3. Okay, so now obviously how many carbon atoms are here? Let's make this very fast. 1, 2, 3, 4. Okay, but if we are numbering, we have to what? Give what? Odogu to what? To this OH group. Okay, so this will be what? We'll start numbering from right to left, obviously. So 1, 2, 3, 4. So it's on position 2. All right. But the methyl group is on what? On the position, on what? On position what? 3. So that will be what now? 3 methyl. Then what? How many? Is it boot? Boot, yes. 1, 2, 3, 4. That is what? 4 carbons. So 3 methyl butan what now? 2 all. Very simple as ABC. 2 methyl butan 2 or 3 methyl butan 2 all. Very easy. All right. So please make sure you just go over all this over and over again. All right. So only you just all the structures, name them by yourself. Okay. Do not forget to like this video. Liking the video will make other students easily find this video. Abi, you know what made a pass through? Please like the video now before you continue. Do not forget to subscribe to this channel. Subscription is free. It's just to send notification to your phone and devices that all 3 schools have just published a new video. What's more again, share, keep sharing. Do not be selfish. Share to your class group, share to your Facebook, share to your WhatsApp, and all other platforms that you belong to. Okay, let everybody learn and pass. Now, let's continue. Let's say we have another structure. Let's take this a little bit higher. Let's say we have 1, 2, 3, 4, 5. And then let's say here we have what? OH. Here we have what? OH. You see the same thing? And then let's say here we have what? A methyl group. Okay, and then here we have what? A methyl what group. Okay, so there's no even need to be putting all these ones. Okay, just know that if you see a structure like this, a stick form like this, and then you now see what is something coming down like this, something coming down like this, just know that what that there are methyl groups here because there will be 1 carbon atom here, 1 carbon atom here. Okay, so let's go. So we have what 2 methyl groups, we have what 2 hydroxyl group. All right, now what do? We find the first of all locate the longest continuous carbon chain of what? The longest chain of continuous carbon atoms rather. So this will be 1. If you number from right to left, 1, 2, 3, 4, 5, 6. Okay. Okay. So we have 6 carbon atoms. That is what? An hex. Let's keep that one by the side. Hex. So 6 carbon atom hex. Then the position of the OH group. If you number from right from left to right, this will be 1, 2, 3. Sorry, not 3. There will be 3. 1, 2, here 3. Then here 4, here 5, here 6. Okay, so we have what? The OH group on what? On carbon 6. Sorry, on carbon what? On carbon 2 first. Carbon 2, and then on carbon what? 6. But if we number from right to left, this will be 1 now. Okay, let me take this off. So this will be 1. This will be 2. This will be 3. This will be 4, 5, and 6. So we have our carbon atom on position 6 and on position what? On position 5. You can see here. Sorry, not position 6, on position 1. Okay, position 1 and what? And on position 5. From right to left, position 1 and position 5. Now, which one is the shortest? 2 plus 6 is what? Is 8. 1 plus 5 is 6. So numbering from right to left will favor us now. Okay, hope you get that part. That is the first mass you need to solve. Once you solve that, everything becomes easy. Okay, so this will be our correct numbering. Then we have what? Our OH group on what? On carbon 1 and on carbon 5. We already know that what is there are 6 carbon atoms on what? On this what? Parent chain. Then here there's a methyl group here. Methyl. There's also what? A methyl what group here. On which carbon atom are this methyl group located on? They are located on carbon 2 and on carbon 4. Okay, so I'm going to have 2, 4. All right, 2, 4. What now? Di, because there are 2 methyl group on this structure. Dimethyl. Okay, then I'm going to have what? Hexane. What now? Hexane 1, 5. Hexane 1, 5. Then what? Diol. Simple as ABC. So 2, 4 to denote that what? That the methyl groups and what? On carbon 2 and on carbon 4. Then dimethyl to say that there are 2 methyl groups. Then hexane, because there are what? 6 carbon atoms on the parent chain. Then 1, 5, the positions of all those hydroxyl functional group on position 1 and on position 5. Then diol to denote that there are 2 hydroxyl functional groups in the structure. It becomes very easy, right? Let's take this a bit further. Very easy. It's interesting. It's sweet. It's easy. Once you know it now, it becomes more easier. It's the easiest. So let's take this a bit further. So let's say we have something as simple as this. Let's say we have what? A cyclic compound. Somebody will run now and say this is benzene. This is not benzene. Okay, if there was one O structure here, then this would be a benzene ring. Okay, so this will have been phenol. This should have been phenol. All right, it should have been easily be what a phenol. Okay, but of course, there's no this. This is not here. This is just what to show that it's a cyclic compound. Okay, and of course, because of this, we just call this what cyclohexanol. Why? Because we have 6 carbon atoms 1, 2, 3, 4, 5, 6. There are 6 carbon atoms, so you simply call this one what cyclohexanol. Okay, cyclohexanol. All right, it's as simple as ABC. This is not a benzene ring. Okay, this is a cyclic. This is what cyclohexane. Okay, so that's what I call it cyclohexanol. Cyclohexanol. So let us just take the last example. This one promises to be very, very, very easy. So let me introduce let's say a double bond to the structure. Let's say we have something like this. Okay, and then let's say here we have a double bond, and then here we have OH. All right, simple as ABC. Here OH, here there's a double bond here, like this. Okay, there's a double bond here between the second and third carbon. Okay, if I'm numbering from the left to the right. So now, this is an alcohol, all right, and of course also the alkene functional group, all right. This double bond is C on what? On the same position. Okay, so now let us number. We have to take credence to this alcohol. All right, this is 1, this is 2, this is 3, this is 4. Okay, so the double bond is between 2 and 3. Right, between the second and the third carbon, and then the hydroxyl functional group is on the second carbon. Okay, so now how many carbon atoms are in the parent chain? First of all, 1, 2, 3, 4. All right, so to name this compound becomes very easy. We know it's a butane. Okay, butane. Okay, butane. Then we also know that the hydroxyl functional group is on the second carbon. So to name this becomes very easy. We simply say this is a but2 in. Okay, a but2 in. All right, reason being that if you number the double bond is on the second carbon. Okay, look at this 1, 2. You now meet the second carbon. You meet the double bond 1, 2, the double bond. That's why I say but2 in. But2 in, then 2 all. But2 in, 2 all. Okay, just say but2 in, then 2 all. Simple as ABC. All right, so the positions of the hydroxyl functional group, the position of the double bond has been represented but because there are 4 carbon atoms in this chain. Okay, that's but2 in, then 2 again, all for the alcohol. So very, very easy. So let us quickly just jump to the OTB School JAMB CBT practice app now. Take the questions from JAMB Past Questions that have been set concerning this. So we do not just teach you, we teach you because we know that we are going to face them. So now let me draw that structure. 2014 number 40. 2014 number 40. Here we have C. Here we have OH. Okay. Here we have chlorine. Here we have bromine. Here we have H. Okay, let's complete our structure now. All right. H. Simple. So now this is what we have. So what do? First of all, give our red cap to the OH functional group because this is an alcohol, first of all, to start with. All right. This one, they are halo groups. All right. So now let us go. Let's number. Obviously, numbering will be from from left to right. 1, 2, 3, 4. Okay. So our OH is on the first carbon. Now, then we have bromine on the third carbon. We have chlorine on the second carbon. Bromine comes before what? Bromine comes before what? Before chlorine. So that will be now? 3 bromo. Okay. Then 2 chloro. 2 chloro. Then is this butanol? Okay, because it's on the first carbon, can just say butan. Instead of say butanol, just say butanol to show that it's on the first carbon. Okay, if it's on the second carbon, we'll have indicated as it's butan 2 all or butan 3 all. So okay, you can just say butan 1 all. All right, you get. But if butan 1 all is not the option, just go butanol because they are trying to tell that the OH group is on the first carbon. That is why, as if from the option, there's not like butan 1 all there. All right. So it's trying to show that the OH group is on the first carbon. If it was on the second carbon, okay, there's no way we'll not see butan 2 all or butan 3 all. All right, as the case may be. So let's continue. This will be 3 bromo, 2 chloro, then butanol. So let's look for the option that has that 3-bromo 2-chlorobutanol. All right, that is what option A. Simple as ABC, Abi. Okay, so we are going somewhere. Let us take another question from O3 Schools JAMB CBT Practice App. This is a 2011 question number 46. 2011 number 46. This is 1, 2, 3, 4. Okay, this is a chloro group here. Yes, chlorine again. Yes, H. Yes, H. Yes, H. Yes, H. Yes, OH. Yes, H. H. And H. Okay, so we're told to what to name this compound. All right, locate the position of your hydroxyl functional group. This is it. This is it here, right? So let us number. That means numbering will favor from left to right. It will be 1, 2, 3, and 4. Okay, so now how many carbon atoms are in the parent chain? There are what? There are 4 carbon. That's the boot. Okay, keep that one or keep that one also. Okay, that's the OH is on the second carbon. There's a chlorine atom on what? On the 4th carbon. All right, and another chlorine atom on the 4th carbon. So we haven't got 2 chlorine atoms on the what? On the 4th carbon. Look at it very well from your question there. Yes, chlorine. Yes, chlorine. All right, so now that is the only other substituent that is present. So that becomes what now? 4, 4. All right, 4, 4. Dichloro. All right, dichloro. That is the halo group here. Dichloro. Then what? Butan 2 all. All right. Actually, in this question, we're not actually asked to name it. Please read question though. Read question before you start dropping. See me now. You see me, mommy. All right. So yeah, we're not actually asked to name the compound. We'll ask the functional groups that are present in the what? In the structure, the functional group present. Okay, like we have an OH functional group, which is what? The hydroxyl functional group or the alkanol. They will now have this chloro, which are what? Halo groups. That is all halogen groups. All right. So the correct answer there will be what? Will be option D, hydroxyl, OH, and halo group D. So please take note of that. So these are what? Questions on the application. There are many more. Okay, there's another question. Let's quickly see one more question here. There's another question here. All right, there's another question here. We're told to what? To name this compound. This is 1998, number 41. 1998, number 41. All right, the previous question is 2011, number 46. 2011, number 46. This is 1998, number 41. All right, we're given the structure CH3, CH2. Okay, I'm giving CH, then CH3, 2. All right. To show that what these 2 methyl groups are what on this carbon. Let us draw the structure out completely. I'm going to have C. Okay, H. This is what it means. Then bonded to what? CH2, H. Then of course CH. Okay, I think there's an OH somewhere. Okay, yeah, there's an OH here. All right. So OH here, then here H. Then this now CH. Okay, sorry, C. Then I have what? H. Yeah, CH3. Yeah, CH3. To show that there are 2 methyl groups on what? On the 4th carbon. 2 methyl group on the 4th carbon. So that our structure is complete. So first of all, 4 carbon atoms in the parent chain gives us what? Boot. Now, numbering will give favor to what? This OH group. So we have to number from right to left. 1, 2, 3, 4. Abi? So now I'm going to have what now? 1, 1. All right. 1, 1 what? Dimethyl. Okay. Then what? 4 carbon atoms. Butan. Position of the functional group 2 all. Let's see. That's 1, dimethyl butan 2 all. That is option D. All right. So please, there are thousands of other questions on this wonderful application. All right. Please go and look at our testimony and see how our students are performing. In fact, last year was a huge success. A lot of 300s. If you want to get your admission, pass your JAMB first. All right. So please jump on the application immediately, download and activate it for a little token. All right. Pay the sacrifice and pay immediately and quick and start practicing immediately. All right. My name remains Master T, the Grand Commander of this great army. All right. Please, if you are an O3 school soldier, you have to make sure that what you keep marching, you keep studying. All right. Do not rest on your laurels. All right. My name's I'll see you in the next class. Right. We'll talk about preparation of alkanols. See you in that class.